According to the EPA, one car produces around 10,000 pounds of CO2 a year. Millions of tons of CO2 from the millions of cars in the US leads to more climate change. So then, are we doomed? Well, not exactly, since companies like Shell plc have decided to combat climate change by inspiring the young generation of thinkers through Eco-Marathon. Eco-Marathon inspires teams to create highly fuel-efficient cars. Penn State Shell Eco-Marathon team achieved 4th in competition this year with a 356 miles per gallon fuel range. To improve our performance, the Future Car team set to create a new bottom frame for the Future Car that'll be much stronger and lighter than the current one. Future Car team consists of 5 team members, with Alex Dietz being the team leader, overseeing the group's responsibilities and leading the group meetings. Scott Catherine is our project scheduler, arranging our meetings and making sure everyone is completing their task on time. Jackson Petula is our manufacturing lead and editor, reading and editing our reports before submission. Ian Rivera is our CAD lead and chief financial officer, ensuring that our budget is well documented. Samir Rahman is our team recorder and the one who primarily takes notes during the meetings. To create a new and improved bottom frame, the team needed to study the current car's bottom frame. Current car's bottom frame weighs around 25 kilograms and was manufactured using square tubing. Further research into statics, manufacturing, past Eco-Marathon and FSAE teams revealed that round tubing is much stronger in bending and torsion than square tubing. Still, square tubing is much easier to handle when manufacturing. After going through many iterations between the team and the sponsor, the team came up with this general design. Still, we needed to figure out what dimensions of tubings we were going to use. Thus, the team did a real-life and CAD FEA to evaluate what tubing outer diameter and wall thickness dimensions provided large moment of inertias, preventing the engine and seating mounts from bending, since the person's weight and the engine weight were our 2 main force constraints. Our final design, as shown here, satisfied our 2 main force constraints and the dimension constraints put onto us by Eco-Marathon. We also worked on creating a collaborative workspace for Eco-Marathon using SOLIDWORKS 3D Experience. Here, we show a demonstration of changing a dimension in the CAD model and seeing it back in 3D Experience. After changing the dimension, we open 3D Experience to the task space, create an account, log in, and then click on the part to create a new revision that you can then see in the bookmark editor of the collaborative workspace made for the team in the 3D Experience dashboard. You can then open this revision using the SOLIDWORKS add-in. To manufacture our final design, we tube notch all the tubes with their corresponding hole saws so that we could weld them all together and create our bottom frame. This is our final design, which had a mass of 9 kilograms and a factor of safety of 1.7. Future work involves developing the top frame and body of the car.